Hey guys, my name's Angel and welcome to About Scala. Scala is a primarily functional, high-level programming language which allows the programmer to take an object-oriented approach. It boasts that its static types assist in avoiding bugs with applications that have more complicated moving parts and was designed by Martin Odersky. Odersky's journey to the design of Scala began in 1995 when he learned about Java. He teamed with Philip Wadler, an American computer scientist, to develop a functional language that would compile into Java bytecode, which is the instruction set for the Java virtual machine. He learned a lot on this project, and in 1999 he joined EPFL, a cosmopolitan science and technology institution located in Europe. At EPFL, he utilized his academic freedom to work in a language that combined functional and object-oriented programming. After learning about the joint calculus, a formal basis for the design of distributed programming languages, Odersky used it as a foundation for this new language. This resulted in Funnel, a programming language based on functional nets that combined functional programming with Petri nets to form a programming notation. Funnel turned out to be not very writable due to its minimalistic nature, and in 2001, Scala's design began as a result of Funnel. Scala first released in 2003. When hearing the fact that Scala translates into Java bytecode, it's easy to form the assumption that Scala is an extension of Java. While Scala is not an extension of Java, it is able to work with and exchange information with it. Because Scala translates into Java bytecode, it is usually just as efficient as compiled Java programs. The design of Scala focused it being both object-oriented and functional. Scala was object-oriented as objects were defined by classes and every value was an object, and it was functional as every function was a value, with functions being able to be nested. There are some big technical and business reasons for using Scala. One such reason is the language complexity. Scala has a handful of basic constructs that can be combined to make the language more flexible. A lot of great Scala work is a result of combining higher kinded types, which is abstracting over type constructors, implicit parameters, which is objects that methods belong to, and subtyping, which is type polymorphism. Another reason is that Scala makes it easy to write code using immutable data. All of Scala's standard data structures are immutable. Immutability provides a myriad of benefits like improved performance, state machines, thread safety, and easier testing. By nature, all fields of an immutable object must be marked final. Every field being final means values can be cached, which ultimately leads to improved performance. State machines also serve as another benefit as it provides less room for error. A field can no longer be forgotten to be updated because you would have different immutable states to go to and from. Thread safety is another benefit as sharing mutable objects across threads can sometimes cause issues. One thread can update the object while another thread updates the same object according to a different state. Immutability leads us to always be in a consistent state. These states result in easier testing. In order to test the entire flow of a program, we only have to test the transition from state to state. We don't have to test every method and how it affects the object. As mentioned earlier, Scala is a mix of functional and object-oriented programming. Let us look at the function programming side of Scala. Simply put, functional programming is programming through functions that are referentially transparent. If a function is referentially transparent, it means that replacing an expression by its bound value does not change how your program works. Pure functional programming has no side effects, which are breaks of referential transparency. Scala, allowing for pure functional programming, allows for many advantages, like being easier to understand. Pure functions do not change states and are dependent on the input. The value returned by the function is the same as what is outputted by the function. They also take in arguments once and produce an output that is immutable. Because of this, they are easier to understand than other programming paradigms like object-oriented. Scala has the standard numeric data types one expects from programming languages: Boolean, byte, short, int, long, float, double, char, string. In Scala, these data types are not primitive and are instead objects. The table below lists the data types and what can be contained in them. Scala has 5 main collection classes that are commonly used. An array buffer is an index mutable sequence, a list is a linear immutable sequence, a vector is an indexed immutable sequence, a map is an iterable sequence that consists of pairs and key values, a set is an iterable collection with no duplicate elements, and both the map and set classes come in mutable and immutable versions. Scala's functions are like functions in other languages in the sense that they are a collection of statements that perform a task. Scala functions are first-class values, meaning they can be passed around the same way as integers, sequences, etc. Generally, if something is first class, it can be used akin to regular values like integers. For example, it can be passed and returned from functions. It can also be constructed just like a regular value, locally in an expression, etc. And it can also be written similarly to regular values as there are types assigned to functions. In Scala, there's a difference between a function and a method. A function is an object that can be stored in a variable, while a method must always belong to a class which has a name. Essentially, a method is a function that is a member of an object. Scala contains the common if-then-else, for loops, and try-catch-finally control structures that are seen in other programming languages, along with the more unique match and for expressions. Scala's if-then-else control structures work almost identical to those we've seen before. A conditional is evaluated, and the program executes certain blocks of code according to the result of the conditional. Scala's if constructs always return a result. Scala's for loops work the same as in other languages, and there is a for each method that is available to Scala collection classes. Scala's for expression is used to create new collections from existing collections, while Scala's for loop is used for side effects like printing output. Match expressions are like Java's switch statements, along with try, catch, finally, which also works how it does in Java, as it allows the programmer to catch and manage exceptions. Scala provides packages that allow the programmer to create, open, read, and write a file. However, Scala's standard library does not have a class to write into a file. Because Scala can make use of Java objects, java.io can be borrowed along with things like java.io.file and java.io.printWriter. Because functional programming involves the use of values similar to that of arithmetic, there are no null values or exceptions. However, that does not mean that Scala omits error handling entirely. Option sum none is a solution to checking for values that could potentially not exist, in other words, null. If a value var might not exist, an instance of option of var may be used as var's container. Option is either an instance of case class sum when the value is present, or case object none when it is not. Try, success, failure works similarly to option sum none, but introduces two more helpful features. Try makes it simple to catch exceptions, and failure contains an actual exception message. Scala has many applications, as it is a general-purpose programming language. But to be more specific, Scala is particularly good at big data and machine learning. Big data involves extremely large data sets that are too large or complex to be analyzed through traditional data processing software. Typically, the data is going to be analyzed for information like patterns or trends, and Scala has been a big player in the world of big data. A lot of important and useful tools for this data are intentionally built in Scala. Some of these tools are Spark, Scalding, and Kafka. Apache Spark is a general-purpose engine for large-scale data processing that is very fast. Scalding is a Scala API developed by Twitter to provide functional operations to be used in typical analysis scenarios regarding big data. Apache Kafka was developed by LinkedIn in Scala and Java to provide a high-throughput, high-efficacy platform to handle real-time data feeds. All in all, Scala is a general-purpose programming language that combines object-oriented and functional programming, and its functional aspects allow for revolutionary platforms written in Scala to be used for big data. Alright, let's hop in the IDE here and take a look at the syntax for Scala. First off, // is still how you would do a comment. This is going to be the wildcard import, where you just want to import the whole collection and not just one function. This is going to be the selective import, where you only want to import just a vector, for example, or if you want to import just vector and sequence and nothing else, this is how you would do that. If you want to rename your import, this is how you would do that as well. And then this is just going to be a class or an object. This is how you would declare a variable. As you can see, Scala does not require you to use semicolons. You can, you don't have to. Scala kind of already assumes, depending on what data type you're pushing into it, what the variable type is going to be. In this case, it's going to be an integer because we're passing 1 to it. If we, for example, change this to 1.0, it's just going to automatically change itself to a double. Here is how you would declare a constant. You would just do value instead of variable. A value is evaluated once and it is not reassignable, which is what makes it a constant. This is where we will define our functions. You'll just do def or definition, add 1, and then here are our parameters, x, integer, and then this is where we define the function. This one just adds 1 or increments whatever we're passing in. This is a function say something. S is going to be, we're passing in any here, which is going to let us pass in a string and let us print line this. Here we're passing in an integer by value, and here we are passing an integer in by the name. Here is going to be our data structures. Here is a tuple, which is going to be literal. It's just parenthesis 1, 2, 3. Here we have an immutable list. Here we have a simple if-else. If, check this boolean here, execute in, if not, else, out. Here we have a simple while loop. Here we have a do while loop. Here we have a for loop. As you can see, it is very similar to Java. You can see some similarities if you wanted to in C, but it is very familiar looking. It's not too complicated, and that's Scala. And today's video was brought to you by Raid Shadow.